Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh and very good evening. I'm Muhammad Rizal Mustafa, Associate Professor at Department of Civil and Environmental Engineering, University Technology Petronas. Today I am the session chair of this session, the Green Environment and Smart Water Resources Management. So in this session, we have a total 7 presenters. There will be 10 minutes for the presentation that will be followed by 5 minutes Q&A session. So without any further ado, let me read the first presenter. The first presenter, we have Mr. Muhammad Ilyas. He is assistant professor at University Malaysia Pahang, and he is going to present on a proposed framework of life cycle cost analysis for petrochemical wastewater treatment plants. So please welcome Mr. Muhammad Ilyas.
Hello everyone, this is Muhammad Ilyas, a PhD scholar at University Malaysia Pahang. I'll be presenting in this conference on the topic. The topic of the presentation is a proposed framework of life cycle cost analysis of petrochemical wastewater treatment plant. So this is the topic, and the outline of the presentation includes introduction, methodology, the proposed framework, which is the main part of this presentation. Framework includes purpose of LCC, cost components, selection of LCC model method, data collection, LCC calculation, uncertainty analysis, and finally conclusion and future research. The introduction includes 3 main parts. The first is about petrochemical wastewater. Petrochemical wastewater contains various organic and inorganic components. Appropriate treatment is required for reuse, discharge, or final disposal. The composition of wastewater and environmental regulation requires a combination of different treatment methods in petrochemical industries. Wastewater treatment plant is a combination of various processes to treat wastewater and reproduce environmentally safe water. The process may include filtration, clarification, biodegradation, oxidation, ozonation, and sludge disposal. Malaysia has made it mandatory for industries to have wastewater treatment plants and made regulation for wastewater treatment plants to ensure the discharge of environmental friendly and safe water. The quality of effluent from treatment plants is regulated by Environmental Quality Act 1974 and its regulations such as the Environmental Quality Regulation 2009 and Environmental Quality Regulation 2009. The first one is for the sewage and second one is for the industrial effluent. Since wastewater treatment is mandatory in petrochemical industries and priority agenda of national government and international organizations, their economic, environmental, and social sustainability should be properly assessed. Recycled industrial wastewater could be a potential water source for agriculture and industrial use. For the economic analysis of wastewater treatment, life cycle costing has been used as an efficient tool. Life cycle costing referred to traditional approach devised in 1930 when the U.S. General Accounting Office included operating and maintenance cost in public procurement. The main purpose of the life cycle costing is to not only include the initial cost, but also include the operation, maintenance, and finally the decommissioning cost or disposal cost. The problem with only capital cost or initial cost is it's only the tip of the iceberg. If we look into the Total cost, life cycle cost, operation and maintenance cost is a major component in the overall cost of any product, process, or project. So this is with this introduction, the aim of this paper is to develop a framework, an easy to use framework for life cycle cost analysis of wastewater treatment plant. The methodology we used for the development of framework includes review of existing frameworks. There have been a number of frameworks, so we reviewed those frameworks and identified their strengths and weaknesses. And then we used Dolphy technique and we interviewed a panel of experts, not only from the industry but also from the academia. And with them, we identified various cost components, cost background structure, and then finally we developed the life cycle cost analysis framework. The proposed framework, which we are proposing, includes kind of 6 steps. The first step is the purpose of life cycle cost analysis, then to identify cost categories and cost components, and then selection of life cycle costing model or methodology, then data collection techniques, then calculation of LCC, and finally the analysis to select best alternative based on uncertainty and sensitivity analysis. So these are the steps involved. Now I'll talk about these steps in detail. The first step is the purpose of LCC. LCC has been used for different purposes, which may include affordability studies, source selection studies, or alternate selection studies, or comparative studies. Then design or process trade-off studies, repair level analysis, warranty repair cost estimates, and then finally supplier sales strategy. So LCC could be used for these different purposes: affordability, source selection, and these different purposes. So the second step is identification of cost components and cost categories. So LCC not only include the initial cost, but it also include operation cost, repair and maintenance cost, and finally decommissioning and upgradation cost. Initial cost can be further divided into different components or categories, such as the installation cost, the equipment cost, the maintenance and testing cost at the initial stage, then operation cost. The major operation costs of the wastewater treatment plant includes the electricity cost, the maintenance, the electricity cost, the fuel cost, and the management cost, and decontamination cost. So these are the major operation costs, then repair and maintenance costs, and finally decommissioning or disposal cost. Sometimes we use replacement cost or upgradation cost instead of disposal cost. So these are the major costs which are used for calculation of life cycle cost analysis. Next is selection of LCC method or model. LCC could be calculated or estimated based on mainly three different methods or methodologies are used for the estimation of LCC. The first one includes engineering, estimation by engineering, which result into the most accurate results, and it includes the detailed cost information about any wastewater treatment or any product or process. The second one is parametric estimation method. We used cost estimation relations and estimate the different costs based on parametric estimation. It's a kind of regression which includes independent dependent variables to estimate various cost components. And finally, estimation through analogy. Through analogy, we also estimate we can estimate the cost of a wastewater treatment plant in comparison with the existing same kind of plant. So analogy could be used for the estimation of LCC. Parametric estimation also include artificial neural network based estimation or fuzzy logic based estimation. So these are two modern techniques which are used for estimation of wastewater treatment. Beside these, certain accounting methods are also used for estimation of life cycle cost. For example, activity cost based costing could be used for LCC. And then data collection. Under data collection, the first is to identify the data source. Data could be internal or external, or data could be from the existing literature as well. So we need to identify the source of the data, whether we are going to use internal data, external data, or data from the existing literature. Then usually we get the data which is not in the format to be used for LCC calculation. So we need to prepare the data. Usually financial data or cost data are not in an appropriate format which could be used for LCC calculation. So we need to prepare the data. Finally, data estimation. If we don't have, since LCC is about the future cost, and future is always uncertain, so we need to estimate the data, and for estimation usually we use parametric estimation methods, or we can use other methods as well. Then LCC, we can calculate LCC through by adding all initial cost, operation cost, maintenance cost, and finally disposal cost. Then what we do is, in order to take care of the inflation, we calculate the future value, then we discount the future value back, so that we could take care of the time value of the money, and finally we calculate net present value, which not only take care of the inflation but also take care of the time value of the money. And then uncertainty. So as I mentioned earlier that uh, forecasting of the operation cost is about future, and future is always uncertain. So we use different methods to take care of uncertainty. We can use deterministic models, which include sensitivity analysis, which has been widely used as a deterministic tool model. Then we can use possibilistic models, fuzzy logics, or Markov chain, or these could be used. Then finally, probabilistic model. Probabilistic model includes probability density function, and we can calculate uncertainty through probabilistic model. So these are three different ways to take care of the uncertainty. And finally, conclusion and future research. So, based on the research, we conclude that this framework could be used for life cycle cost analysis of wastewater treatment, and it's an easy to use framework. Future research directions include, we also need to take care of the environmental cost, and we need to devise a framework to include environmental cost in the analysis. And then we can use process costing techniques such as ABC or time-driven activity-based costing for accurate estimation of overhead cost. And then finally, LCC and LCA has been widely used in wastewater treatment, so we need to devise a framework for parallel LCC and LCA studies. So this is all about today's presentation. Thank you very much. Thank you.
Okay, thank you very much, Mr. Muhammad Ilyas, for the very interesting presentation. So let me see if we have any question from the audience. Yes, we do have. Does these methods used in the industry presently?
It depends on the industry actually, and again it depends on the country. In countries like United States, in countries like Norway, Denmark, they have made certain regulations to use life cycle costing instead of only initial investment cost. So there are international standards for certain industries like construction industry, like a petrochemical industry. But as far as wastewater treatment is concerned, there is no standardization of the framework. And countries like Malaysia, the adoption of life cycle costing is very slow. Although Public Works Department encourage use of life cycle costing, but still we lag behind from modern countries like United States and
Okay.
others.
Okay. It seems a topic is very interesting because we are getting more questions here, but due to the just time constraint, I think I would be able to take only another one question. Is there any benchmarking for wastewater?
Uh, Benchmarking means there are quality standards. There are quality standards. For example, these environmental, this Act 1974 and Savage regulations, they identify the certain benchmarks which can be used as a standard for the.
Okay. Okay. Thank you very much. There are few more questions from the audience. Perhaps due to the time constraints, we just need to limit the number of questions until here. And I think rest of the question, perhaps you can just meet in the meeting hub. Perhaps you can just drop the question. We can also help you to connect with the presenter. Thank you very much, Mr. Muhammad Ilyas, for the nice presentation.
Thank you for having me. Thank you for having
Okay.
me.
So let's move to the next presenter. Next, we have Dr. Noor Azlina Batini, and she is presenting on performance of permeable pavement with subsurface micro detention storage as rainwater harvesting devices. Yes. So please welcome Dr. Noor Azlina Batini.
Assalamualaikum and a very good morning to the audience. I'm Dr. Norazlina binti Batani from University Malaysia Sarawak UNIMAS. My paper title is about stormwater management infrastructure, performance of permeable pavement with subsurface micro detention storage as rainwater harvesting device. Urbanization foresee the occurrence of flood events due to land development, road system and impervious surface, consequently reduce the pervious area and occurrence of flood events. Therefore, sustainable development is vital through urban stormwater management. Urban stormwater management balances the elements such as environmental protection, economic growth, and social consideration while planning for the development. One of the major source control in stormwater management is application of green infrastructure. In this research, I am focusing on the permeable pavement and connected with underground rainwater harvesting system which considered as green pavement infrastructure for stormwater management control. This research is part of study on StormPav. StormPav have been developed by a group of UNIMAS researchers since 2013. It is a product of an industrialized building system which uses precast honeycomb structures, consists of three components, top, bottom and middle section which form a single modular unit. The StormPav consisted of 4 mm diameter hole in the center, allowing water to flow to the next level with mid section and a hollow cylinder in a rain barrel shape to store water. The properties included 70% wide capacity and 450 mm thickness with design storage capacity at 190 liter per meter square. Figure 1 shows the StormPav with three components, top, bottom and the middle section in cylindrical barrel. Figure 1A shows the comparison between StormPav is in the right hand side, and conventional pavement, permeable interlocking concrete pavement, permeable pavement is on the left hand side. You can see that the StormPav give us micro detention storage in the between to store the rainwater. The objective of this study is to investigate the performance of StormPav to be used as component of rainwater harvesting in the tropical climate of Kota Samarahan and to examine water quantity level at various storm events and the implication of an incremental wide capacity and thickness level to the infrastructure. Next, we move to the research methodology. It is divided into two two major parts: laboratory experimentation and simulation using SWIM in LID practice. Figure 3 shows the experimental setup to test the water holding capability or storage capability at various storm events. The tests were conducted under simulated rainfall at Hydraulics Laboratory of UNIMAS. Next, this figures shows the rainfall, the depth of water in storm path structure and volume capacities at 10 years average recurrent interval at various storm events. The figure shows the performance in terms of water depth for the investigated rainfall event ranging from 65 mm to 175 mm per hour for a fixed duration of 3 hours. Since the total height of the storm path is about 0.45 meter, the system shows its ability to fully capture rainfall event with the intensity less than 80 mm per hour for continuous 3-hour duration, in which this is equivalent to almost 2-year events at 24 hours. Figure B demonstrates the volumes of water that is collected for each 10-year event from 15 minute to 3-hour duration. It is noticed that for all the cases, the collected water volume is within 0.7 meter cube to store water at the study area of 4 meter square. Therefore, showing that storm path able to store water for a 10-year rainfall event at the studied catchment. Next, we move to next figure illustrate the storage capacity of the system within the initial 6-hour duration for 2, 5, and 10 years event. In Kota Samarahan, average rainfall event is about 350 mm. For storm path design, the effective storage capacity is about 315 mm inside 450 mm subsurface micro detention storage, which is equivalent to 5-year 24-hour rainfall. From experiment, figure 5A and 5B satisfy the volume requirements during continuous 6-hour rainfall event for 10 years average recurrent interval. Next, figure 6 presents a further analysis on the storm path using different catchment area from 10.5 meter square to 12.5 meter square, which is the standard local car park size, and the respective storage volume is about 2 meter cube to 3 meter cube. An indicative volume for the stormwater component was 2 meter cube for a standard house. Thus, the storm path fulfills the criteria of the stormwater component, in which storm path only can store water about 0.8 meter cube within the specified area. In figure 6A, the rainfall intensity applies was for 10 years rainfall event for continuous 12-hour duration. 10 years for continuous 12-hour duration, with the maximum rainfall depth of 312 mm, similar to the storm path effective storage design depth. Furthermore, the maximum rainfall volume collected was less than 0.8 meter cube, which was 60% less than the total volume. The storm path can provide a detention volume of less than 2.5 meter cube to convey to an underground rainwater harvesting tanks. Besides, figure B and C provide rainwater harvesting tank size of less than 8 meter cube volume capacity. The duration was less than 30 minutes within the typical time of concentration for small urban watersheds. Next figure. Next is on table 1. Table 1 shows the recommended maximum height of storm path cylinder based on 24-hour rainfall. When it is calibrated in the same 5.1 shows a good fit between the simulated and measured water depth as confirmed by determination coefficient R² of 0.993. Table 1 shows the recommended height of the storm path represented as a rain barrel in swim and maximum amount of water depth collected in the system. From the Kota Samarahan rainfall record, April to September received less than 10 mm of mean monthly rainfall. And from table 1, the relationship between rainfall and storm path depth give a linear trend line whereby the recommended maximum height of storm path should be 1.5 times the rainfall depth received. In conclusion, storm path has shown unique hydrological features which prove advantageous on a bigger space and volume of wet about 60%, 70% of wet capacity compared to other permeable pavement. The experimental results concluded that the storm path can be applied for both rainwater harvesting system as in the micro detention storage and as the permeable pavement with a connected underground storage tank. Therefore, storm path is a promising sustainable green pavement solution alternative for roadwork and detention facilities for rainwater harvesting devices in a hydrological perspective. With that, thank you so much.
Okay, so thank you very much for the very interesting presentation, Dr. Noor Azlina. So let's see if we have some questions from the audience. Yes, we do have. How do you avoid if there are a lot of suspended solids in the feed?
Okay, thank you for the question. For the moment, we apply it only in the laboratory environment only. So future research will be to apply it in the field.
Okay, so let me see if there is any other. Okay, I think no more question from the audience. Let me ask one question from you.
Okay.
Several rainwater techniques. So, have you made any comparison with them, and how you find the difference of the efficiency or in terms of the cost? Any sort of this kind of analysis? If you could please share something on that.
Okay, thanks for the question, Doctor. Actually, for the moment, we are investigating the storm path for only for dual performance for permeable pavement and then for the detention storage. And then one of the research is to see how it acting as the rainwater harvesting in which we connect the system to the underground tank. For the any comparison is only comparison on the cost of the permeable the storm path with other permeable pavement devices, not with the rainwater harvesting system.
Okay, okay. Efficiency, perhaps you have yet to do some some comparison.
Efficiencies in terms of permeable pavement, yes, but in terms
Yes.
of rainwater harvesting, not yet.
Okay, 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 okay. Okay, thank you very much, Dr. Noor Azlina, for
Okay,
the
thank
wonderful
you.
presentations. Let's move to the next presenter. We have the next presenter in line, Dr. Lavanya Balu from University Technology Petronas. And Dr. Lavanya would be presenting on usage of seaweed as a biocomposite material in green construction. So please welcome Dr. Lavanya.
My name is Mubarak Osman Kenkia. I'm here to present a conference paper titled Usage of Sewage Ash as a Biocomposite Material in Green Construction from the University Technology Petronas. The abstract. This study aimed to investigate the compressive strengths of mortar cube based on percentage replacement level from 0 up to 15% to replace cement by seaweed ash. The sample was washed until the pH value was neutralized, then oven dried at 105 degrees C for 24 hours, and later it was burnt at 600 degrees C for 3 hours in a marble furnace. The seaweed granules and seaweed ashes were characterized through Brunner Image and Taylor (BET) field emission scanning electron microscope (PSEM) and X-ray diffraction (XRD). The sample was then used in mortar production, where cement was replaced up to 15%, and the compressive strength was determined at 3 days, 7 days, 14 and 28 days respectively. After the 28 days, the compressive strength test showed that 15% of seaweed ash replaced cement used to produce a mortar with highest compressive strength, higher than the control mix. Therefore, eco-friendly seaweed ash could be used as a replacement material of cement in construction in the production of mortar. Materials and methods. The materials used in this research include seaweed, sharp sand, water, and cement. The method. Point number 1, characterization tests, which include specific surface area of the sample and its pore size distribution. PSEM, DSC, XRD were performed on the seaweed ash to determine its suitability as a replacement material. Water absorption test was conducted according to American Standard Test Method C642-97. Compressive strength test was conducted according to ASTM C192. Seaweed ash characterization. The XRD result revealed calcium oxide is 16%, aluminum oxide is 24%, silicon dioxide is 35%, and sulfur content is 25%. The PSEM image showed clear cellulosic fiber shape with fibril. Water absorption. It can be seen from the table that the mortar that was produced with 15% of seaweed ash has the lowest percentage of volume of permeable voids, around 16.95%. On the other hand, 15% of the granules showed highest volume of permeable voids, about 39.5%. By comparison, the mortar with the seaweed ash showed smallest deviation from the control mix. From the graph showed compressive strength development at 3, 7, 14, and 28 days of curing. Considerable increase of strength was occurred after the curing period was completed. The mortar strength obtained from the average of 3 specimens at 15% replacement level, the seaweed, the compressive strength developed at 28 days is 29.9 megapascal, which is slightly higher than the control mortar, 29.6 megapascal. Conclusion. This paper reports the importance of sewage ash, its utilization as a potential pozzolanic material that could enhance the compressive strength of mortar. The mortar made with seaweed ash yielded higher compressive strength and volume of permeable voids slightly higher than the control compared to mortar made with the oven-dried and sun-dried seaweed granules. The appropriate mix design with the seaweed ash, it can provide better stopping ability and boost the compressive strength of mortar. Natural polymer modified mortar with seaweed ash is very promising to become green construction material for sustainable mortar. The greenhouse gas issue can be mitigated by considering renewable materials such as seaweed. As a recommendation, the various water cement ratios can be introduced to determine the maximum water cement ratio for the maximum compressive strength of mortar can be developed. Thank you.
Okay, very interesting presentation. Let me make a little correction that the paper has been presented by the second author, Mr. Mubarak Usman. And we have the first author here, Dr. Lavanya, with us for the Q&A session. So let me see from the audience if there is any question. Okay. Any question? Okay, yes. Have you investigated the cost effectiveness of using the seaweed in the study?
Okay, thank you to the chair. Yes, when it comes to the course, yes, as I mentioned just now, the second author is my master student who did the experiment. So actually seaweed is something that is found naturally and available in abundance quantity. So for the cost to get the raw material, it's something from natural environment, and also it's always there. So we just have to go to the ocean and harvest. Because another problem, if we do not harvest this seaweed, what will happen is it will cause in the eutrophication problem. So in terms to get the source, it is, I would say, it's free of charge. Just that we need to invest certain amount of money for pre-treatment of acid, which is the cost is not that much.
Okay, so thank you very much, Vanya,
Thank you, Chair.
for the nice the study sharing with us. So if we make its a comparison with some other existing material, so would you please a little bit elaborate that how is the cost analysis with the existing materials, the green technologies?
Okay. With other material, I do not do cost comparisons, but just with seaweed, we have conducted 3 types of treatment. That is, one is oven dry, another one sun dry, another one converting it into ash. So I have done the comparison between these 3 treatments, and of course, turning into ash, we need cost is about 30% sun drying.
Okay, okay. Okay, so thank you very much, Dr. Lavanya. So let's move to the next presenter. Let me read. We have the next presenter with us, Mr. Anwar Amin Hazim. and he is going to present on removal of cadmium from aqueous solution by optimized magnetic biochar using response surface methodology. So please welcome Mr. Anwar Amin.
Bismillah ar-Rahman ar-Rahim. In the name of Allah, the most gracious, the most merciful, and prayers and peace be upon our messenger, sallallahu alaihi wasallam. My name is Anwar Amin Hizam, and today I would like to present my paper. Paper title is Preparation and Optimization Condition of Magnetic Activated Biochar derived from rice husk using response surface methodology. As you know, the background of study, as you know, we have rice husk, which is type of agriculture bio-waste. We need to convert it to biochar by using heating technology, which is pyrolysis. Then we used to have like surface modification of biochar in order to increase the functional growth of biochar, which can be applicable for heavy metals remediation. And you know why we treat wastewater, increase the pollution of cadmium poisoning, death of aquatic lives and human. It's like it exceeds more than 100,000 deaths recorded annually due to the cadmium exposure in the USA. We need to we need the rise in economic development, increase the demand of clean water. And this type of things is caused by rapid urbanization and expanding industrial activities, like a lot of industry which can have like there is a lot of petrochemical industry which use like cadmium as sources, which cause cadmium pollution. Also we treat wastewater to the government legislation. As you know, the maximum permissible limit for the cadmium in everywhere is like less than 0.5 ppm. What is the biochar? Biochar technology? Right now, most people use biochar instead of activated carbon and instead of other commercial absorbent due to the high cost and other type of disadvantage. What is the biochar? It's a fine-grained, porous and carbon-rich materials produced from thermal degradation of organic materials under oxygen-limit condition. In order to produce biochar, there are a lot of technology and production methods like slow pyrolysis, fast pyrolysis, flash carbonization, and also gasification. We use slow pyrolysis. Why we use slow pyrolysis? It has a lot of advantage, which is rapid heating of the sample, reduced residence time and accelerate the reaction, energy efficient and also more controllable. When the pyrolysis is slow, we can control the heating time easily, and also cost effective compared to the other type of commercial absorbent, and also applicable for surface modification. When we have the biochar produced using slow pyrolysis, we can modify biochar as we want, like what we have now. We impregnate biochar with iron oxide in order to get value added of easily separated and regenerated the biochar again and again. The problem statement and significant. Problem statement, as you know, characterize and evaluate the absorption behavior of modified biochar toward the cadmium ions in aqueous environment. Establish proper procedures for the separation and recovery of metal-loaded absorbent from the aqueous solution. As you know, we have the significance of the study. Relief on traditional bioabsorbent like activated carbon, produce as cost-effective and eco-friendly absorbent with the higher absorption capacity and selectivity for cadmium ions. Enhance the recovery and reusability of metal-loaded absorbent via biochar modification. Provide a deeper insight into solution behavior of heavy metals ion in aqueous solution. You know, the objectives of this paper is like to conduct and optimize magnetic biochar as an absorbent for the absorbing cadmium ions from aqueous solution, and also to validate the result obtained from modeling with experimental run. You know, as we know, we have the methodology part, design of experiment. We used to have like a central composite design, responsive methodology. We have three types of input parameters, which is temperature, time, impregation ratio from materials to iron oxide. We have the low temperature and high temperature. As you know, we selected the time and the impregation ratio from previous study, while the temperature of rice husk, we use it using thermogravimetric analysis. And also we have that what we call the theoretical background, which is biochar. How can we find the biochar yield? We're using this equation, removal efficiency using these equations, and also absorption capacity. We used to have the device of converting the biochar of, the raw materials to biochar using tube furnace, which has, you know, external source of nitrogen. Then also we apply what we get. We apply the products, which is absorbent in what we call it in orbital cycle using batch study. After that, we scale up in the other study to the group study. You know, we have the methodology part. We get this value from, you know, randomly from the system. You know, we have 20 run using different temperature, different time, different impregation ratio. We get this one. We apply this one as a, you know, calculation by using the provided equation as I show in the previous slide. We have removal efficiency also. Do you know the final empirical models in terms of coded factors are shown in the equation? We have biochar yield as a, what we call it, response. We have two types of response factors. Response parameters, which is biochar yield and also removal efficiency. We have, you know, this. We get this, you know, the model from the CCD, the Central Composite Design. You know, we get the result now. As you can see here, the predicted value versus actual value. You know, the relation between predicted and actual value of the responses parameters, which is biochar yield and the removal efficiency. You know, the predicted value obtained were very similar to the experimental value, suggesting that the models developed were effective in representing interaction contaction between biochar-based absorbent preparation variables for the two responses, which is biochar yield and also, you know, this we have, you know, the combined effect of process variables. We have the two figures now. As you know, that we have now analysis of variance of magnetic biochar yield and also analysis variance of removal efficiency of cadmium. You see, we have what you call it in this response, the models was significant, and also the two parameters, which is temperature and time, was significant, while the impregation issue was also significant. In this, analysis variance of removal efficiency, the models also was significant, and also the two type temperature and time was significant, but impregation ratio was not significant. But the impregation ratio, it gave also others what called value added to the biochar, which can be, you know, easily regenerated and separated. You know, the result, you know, the optimum result of validation from the mathematical model. You know, we get the optimum temperature 395, 124 times, 0.5 as an impregation ratio, and also the cadmium, what you call it, the optimum result for the responses, for the two responses. We have here, we have cadmium removal, 44 for the yield, and also 94.25 for the cadmium removal. You know, from this table, you know, as you can see, the experimental condition with the highest desirability, we can see the desirability is like about 67. It was 67 point something. We increased it. You know, the desirability was 67. Was selected for the verification biochar, which was prepared under experimental condition, presented in the above table, along with experimental value for yield and removal rate. it was noted that the experimental value obtained were in a good agreement with value determined from the models. We have the conclusion now. By using the central composite design, the study was performed to figure out the effects of three input parameters, which is temperature, time, and temperature ratio, on the output parameters responses, which is biochar yield and efficiency. It was concluded that the temperature had negatively the greatest effects on biochar yield, while the time was the most significant effect on the removal efficiency of cadmium. The R-square value of all parameters shown a good fit of the models with experimental data by analyzing the response surface. The response surface methodology derived from equation. The best optimize is to have the temperature in 395 degrees Celsius and the time in 120 minutes, and also a migration ratio with 0.5. And the best magnetic biochar adsorbent was has the biochar yield with 44, which is in terms of economic, it's very high, and also the removal efficiency was 94.25, which is also good comparing to others commercial activated carbon. This is the references, and thank you so much for listening.
Okay, so thank you very much for sharing an excellent study with us. So now let's see if we have any question from the audience. Okay, so yes, we do have one question for you from the audience. How would this be cost effectiveness versus performance for real life industry?
Do you hear me now?
Yes.
What's the question again?
Okay. How would this be cost effectiveness versus performance for real life industry?
How cost is going to be, in low cost, because we are producing like biochar and like from waste. It's like from agricultural waste, because I'm using like rice husk. Then after that, because a lot of people are using rice husk. Later on, I changed to canaf. Then I developed the products with the surface modification, which can later on do like commercialization, because I'm doing commercialization for the products at the end of the project, which I can compare our products with the commercial activated carbon or others commercial adsorbent.
Okay, thank you. Let me ask another question, just for a little bit further elaboration. You are using the word magnetic biochar. So could you please elaborate further the word magnetic, which is attached with biochar?
Like iron oxide, because I'm like grinding the rice husk to like micro or less than micro nano, in order to like mix it with the iron oxide. Iron oxide might later on increase or improve the functional group of the products, and also it gives like others value added to the products, because when we have the products, you can easily what you call it, you can easily separate it from the wastewater, in order, sometimes, because due to the flow of wastewater is going to cause sludge. So in order to remove this type of products, we are going to use like external magnetic field in order to like what you call it, collect the wastewater.
Okay, thank you very much. Thank you very much for the very interesting study sharing with us. So now let's move to the next presenter. Let me see. We have Ms. Siti Hajar. Yes, we have Ms. Siti Hajar Muhammad Noor Azam from Sime Derby SDN PhD Malaysia, and she will be presenting on assessment of SRTM ASTER and IFSAR digital elevation model in oil palm plantation, river derivations, and basin delineation. So please welcome Ms. Siti Hajar. Yep.
Okay, thank you, Doctor. Good evening to all participants and colleagues. So today's presentation is entitled Assessment of SRTM, ASTER, and IFSA Digital Elevation Model, DEM, in oil palm plantation, river derivation, and basin delineation. So the content of the presentation will be the introduction, the methodology, a little bit of introduction of the DEM, the assessment parameters, and also the data validation, the river network and watershed, and also we go straight to result and discussion, and also conclusion. All right. As for the introduction, flood inundation modeling is usually used to understand, predict, and assess the impact of any flood event. Oil palm plantation is also susceptible to such an event, as such resulting in plant and infrastructure damage and loss to the growers itself. So in an oil palm plantation, the terrain of planted area are usually categorized into flat over coastal, flat over inland, rolling to undulating, and also hilly terrain. DEM, or digital elevation model, is one of the main parametric input to initiate a flood modeling. Hence, understanding the accuracy of the dataset is super crucial. So the study is aimed to meet the following objective. First is to evaluate the absolute vertical accuracy of SRTM as the GDEM and IFSA. Second is to evaluate the elevation profile of these three datasets, and also to evaluate the quality of river derivation and watershed delineation using these three similar datasets. All right. This is the study area, which is located in Sungai Simpang Kiri catchment. So this catchment is located within Segamai, Muar, and Batu Pahat district in Johor, Malaysia. The location of the study area is at the downstream of this particular subcatchment. All right. This is the methodology of the assessment using the three type of the data set, SRTM, ASTER, and also IFSA. Three type of evaluation were made, which is the absolute vertical accuracy, the elevation profile, and also the river network, and also watershed, which is derived from a Q-SWOT. So the validation method used in this for the absolute vertical accuracy is using the ground survey of the elevation data of Trimble R10, and we use RMSE method to assess the result. And then for the elevation profile, we use UAS DEM. UAS is stand for Unmanned Aerial System, or UAV. As a reference. And then for the river network and also the watershed, we use the UAS orthophoto to validate the river and also the watershed. And then from here, we identify the most suitable DEM that can be used for flood inundation modeling. So these are the three data set: Shuttle Radar Topography Mission, SRTM, ASTER, Advanced Spaceborne Thermal Emission Inflection Radiometer, and also interferometric synthetic aperture radar. So all these three type of data are derived from radar technology. And also for the reference elevation, Trimble R10 GNS system are used to collect the data, and we have collected 36 points over the entire study area, which is around 3,000 hectares. And then we use UAS DSM as a reference for elevation profile and also the river and watershed delineation. So as for the statistical analysis, we use RMSE. Elevation profile, we use visual approach, and also a river and watershed analysis using a visual approach as well. So these are the data that we have collected over the study area. So what you are seeing here is the type of data, the visualization of the data itself. SRTM at 30 meter resolution, ASTER at 30 meter resolution, IFSA at 5 meter resolution, and UAS DSM at 1 meter resolution, with this as a legend of the for the display. So in terms of reference of the absolute vertical area, we collect 36 point over the entire study area, which is seen in the icon plus here. And these are the device Trimble R10 that we've collected the data so far. So the table here is indicating the existing quality data, which is the horizontal accuracy and also vertical accuracy of each data set. For example, for IFSA with 5 meters spatial resolution, the horizontal accuracy is 4 meter, while the vertical accuracy is around 1 to 3 meter with 95% confidence level. As for the SRTM, it is 30 meter in spatial resolution, but vertical accuracy is 16 meter with 90% confidence level, while the ASTER 30 meter resolution with horizontal accuracy of 17 meter and vertical accuracy of 10 to 25 meter with 90% confidence level. All right, so once we completed the data collection, we derived an RMSE, root mean square error, for each data set. And from here, we found out that the US data set give the most accurate data as compared to the rest. And the NNSDA is the national standard for spatial data accuracy statistic at 7.634 meter of absolute vertical accuracy. So this is the result for comparing the elevation profile. So we've drawn 5 profiles out of all the study areas, and we have identified that IFSA is the closest to the UAS, our reference here. Okay, so and the third parameters of assessment is the river derivation. So the first picture here, A, is derived from SRTM. This is derived from ESTER, and this is derived from IFSA. So the line, the blue lines here is river digitized from the Google Earth with combination with the UAV data. So we have found out that from SRTM, it gives better response as compared to ESTER. So, and it is even more accurate with IFSA. So in terms of deriving the river network, IFSA will be the most accurate. All right. And then the final one is the watershed delineation. So we are comparing against 2 data here. The first picture is where we derive SRTM from, watershed from the SRTM data. And the one in green here is the watershed delineation that we get from GPS using IFSA data. And then the second picture here is the watershed derived from ESTER GDEM. So you can clearly see from both pictures that SRTM is much more compatible as compared to ESTER for this particular study area. So in conclusion, the study aimed at assessing the 3 types of DEM and to select the most suitable DEM to derive river network and catchment area. So IFSA DEM provide the most reliable data to extract information as compared to the other 2 sources, SRTM and ESTER. And the as for the absolute vertical assessment, the RMSE of the 4.711 meter is pretty much reliable terrain profile. This is due to its final spatial resolution of 5 meter. However, the data are only limited to a small area of 8,600 hectares. As for deriving Sungai Simpang Kiri catchment area, SRTM DEM is sufficient to delineate the boundary. Yes, thank you.
Okay, so thank you very much for the excellent presentation. So let me see if we have the question from the audience. Let me remind the participants here, you may drop your questions in the discussion forum if you are interested to ask any question from the presenter. Okay, let me see. Yes, we do have one question from the participant. Would this method implemented by industry?
Yes. You mean the watershed delineation and river?
Yes, yes.
Yes, it is. It is.
Okay.
It is implemented in industry.
Okay. Okay. Thank you very much. Let me
Welcome.
just ask some brief further information about the DEM. Could you please let us know what is the resolution of the DEM you have used and how the data was acquired?
Which DEM are you referring to, Doctor?
The data, these images you have used, what is the resolution of the data?
All right. What is in the industry with the company now is a 5-meter solution.
Oh.
So it is finer, but the one that is freely available is at a 30-meter resolution.
US Geological Survey. So you are
Yes.
using from your company the 5-meter resolution.
Yes.
Yes.
We are
Okay.
using 5.
Okay. Okay. Thank you very much for
All
the
right.
very outstanding presentation.
Thank you,
Okay.
Doctor.
So let's move to the next presenter in this session. So next we have Dr. Noor Azidawati Harun from University Putra, Malaysia. And she is presenting on features and geomorphic response of mountainous river by reach scale. So please welcome Dr. Noor Azidawati Harun.
Assalamualaikum warahmatullahi wabarakatuh and very good day to everyone. My name is Nur Azidawati Binti Harun. It is an honor for me today to deliver a presentation related to my research. Today I will present about the title of Features and Geographic Response of Mountainous River by Reach Scale. There are about five points that we will discuss today, which is the introduction, literature review, research methodology, and result and discussion. For the introduction, we know that river rehabilitation and restoration is a restoration process in a river, such as channelization, stabilization with the concrete, riprap, interlocking blocks, and other hard engineering control measures also to have made the river out of the natural rivers. So the losses of physical and biological function in altered river have induced large-scale adverse effect by the public throughout the Malaysia. The geomorphology study is still in infancy in Malaysia because the problem, as I mentioned above, is related to geomorphology, where all the activities will affect the morphology of the river. So apart of receiving 3,000 millimeter of precipitation annually, surface water are essential source contribute to the water storage. If the geomorphology of the river has been interrupted or changed then it will reduce the amount of water to supply for the long term. The geomorphology of river is a nature and it is capable of generating abundant and clean water with equilibrium features. Therefore, the focus of this study is to investigate features and geomorphic response for the mountain river in Malaysia. So why the mountainous river is selected? Because we want to know what is the condition of the reference river. Reference river means the river is a natural river without any other activity that will harm the morphology of the river. So the scope of study is limited to mountainous river, which is appropriate for reference condition for high stability features. There are about two objectives has been identified here. First is to identify the type of river morphology and assess the hydraulic features. Second is to investigate the geomorphic response of the river morphology. In the definition for the literature review, the equilibrium of rivers is defined as the ability of a river over time in the present climate to transport the flows and sediment produced by its catchment area in such a manner that the dimension, pattern, and profile are maintained without neither aggregating nor degrading. So what is the geomorphic responses? Geomorphic responses of a river due to the disturbances include riverbed degradation, aggradation of riverbed, river widening, change in longitudinal profile, and variation changes in cross-section geometry. There is an important balance between the erosive power of the flow and the strength or resistance of the bed and bank material to erosion. So there are about four functions of the demographic response. So this is the functional relationship between water, sediment discharge, and the resulting channel, which is the size, shape, and the sinuosity. We refer to the first, which is the widening. As mentioned in the functional, uh, this this equation denote that an increase of water discharge and sediment discharge tendency of response to channel widening. It reflects to the water discharge and sediment discharge. And for the aggradation, tendency of aggradation at riverbed due to the response of increase of sediment discharge and width but decrease in the depth. In this case, the channel is to be aggrading at the riverbank, implying that the channel has filled by the excess of sediment. While the deepening response is tendency of channel deepening due to the response of increased flow discharge without increase in sediment discharge. Okay, while the fourth one, aggrading and deepening, increase in sediment discharge or reduction in the flow discharge will result in reduction of channel slope. This is the tendency of channel aggradation and deepening. So as a recent methodology, there are about five type of river has been selected for doing the data collection. Okay, the five selection rivers has been pre-selected using the REFCON method. Okay, to apply that all these rivers are suitable for reference river. So all the data collection is by extensive data collection. So about 43 of cross section using survey equipment, velocity meter, and total load equipment. The size of wet material will be measured using the Wellman pebble count and measuring tape for the larger size, especially for boulder and cobble size. For the sandy size, the dry sieving analysis will be take the sample to the laboratory. And the bed load and suspended load will use the Halley Smith bed load sampler and the excavation sampler. And then all the bed and the suspended load will be linked to the laboratory for do the analysis. And then what is the hydraulic features that we are obtained? We have the top width, average depth, slope of water surface, average velocity, size of the material, discharge of water, and discharge of sediment. So here is the detail of the location that we have about total 9 cross section from the Ulu Pipe river, and then 8 cross section from the Lepuh river, 8 cross section from the Chongkat river, 8 cross section from the Rasau river, and 10 cross section from the Sky river. So all these five rivers is located at different districts, which is Ulu Pipe River located in Kedah, Lepuh River, Chongkat, and Rasau River located in Selangor, and while Sky River located in Kedah. So this is the result that we get. So from the five type of location, we found out there are about four type of the features of morphology. First is the features of pool river, and then you can see the first photo at A, and then B is the features of cascade river, C is the features of flatbed river, and D is the features of the step pool river. So we can get the range of uh, the range of the features hydraulics. You can see that active width for the cascade is the highest, which is from 5 to 31. And then the average depth, the highest is also goes to the pool river from 0.2 meter to 0.9 meter. And then the flow discharge, the highest flow is from the cascade and the step pool. And the sediment discharge, the slope, the highest slope is from the step pool slope. Okay, so this is the result for the functional relationship. Okay, we do the comparison between the river based on the cross-section to cross-section. And then once we get the data in the cross-section to cross-section, we solve this one in a group of the morphology because we want to see the pattern through the morphology of it. So we refer to this first, second, and third question here is refer to the functional relationship that I show you the formula just now. So we can see that about for 100% of the cascade, 61% shows that there is the river is in equilibrium, while the others there is a various geometric response such as widening, deepening, widening and deepening for the cascade. While for the plain bed, from 100% of the cross section, 88% shows the plain bed are in equilibrium. Plain bed only have a widening process. And then for the pool river, about 100% from the pool river, 63% shows that the river are in equilibrium, while the other shows that there is a widening, aggregation, and deepening response. And then for the step pool, from 100% of the step pool section, 67% shows that the step pool are in equilibrium, while the other shows that the step will have a widening, aggregation, and deepening process. Okay, from here we can see the distribution among the morphology. You can see that all in equilibrium condition, all type of morphology shows a very high percentage because we, as I mentioned just now, we are select the river based on the reference river. So all river must show the highest percentage so that the river is still in good nature of its morphology. Okay, so we can see that for cascade here, about 11% shows that the cascade has the deepening process and 10% we have the widening process. While about 4% of plain bed shows that the river have a widening process, and then about 10% for deepening and 10% for widening process at the step pool. And the pool river, there is an aggregation about 4% and deepening and widening about 8%. So mostly the cross section will shows that deepening and widening is a very common process. But when there is a extra process, extra percentage of the demographic response, so that indicate that the river have a problem of the in terms of the morphology. So as a conclusion type of morphology, there are cascade, step pool, and plain bed morphology, and shows the significant width. The pool shows the significant width compared to other morphology. Cascade and pool shows different depth compared to the plain bed and step pool. And then in this study revealed that cascade, pool, step pool, and plain bed have an important function in the relationship of hydraulic features and geomorphic responses for sustaining the river capability to flow for today and future. So this is the list of references that I have referred for this paper. And lastly, thank you very much for your listening to.
Okay, so thank you very much, T.S. Noor Azidawati, for the very excellent presentation. So let's see if we have a question from the audience. If we don't have, then okay, I ask you one question. You have mentioned there are 4 rivers selected. So, could you please elaborate further that what was the criteria of the selection of those 4 river? And you also mentioned that a mountainous river. So, would it be effective that if you apply the same methodology for the plain area, the rivers in the plain area, how would you differentiate between its application in the mountainous region and the plain area?
Okay, thank you, Doctor. Okay, appreciate your question. It's a good question. Okay, for this study, yeah.
Yes, please
Hello.
proceed.
Proceed. Okay. Can you hear my voice?
Yes, yes, yes.
Okay, thank you very much. Sorry. Okay, we can see that this data has been collected in the mountainous area because we want to see what is the original or what is the non encroachment. So, yes.
Yes, yes, please proceed.
Okay. Okay, we are collecting data because we want to see either the river that has not been disturbed by the surrounding activities, what is the natural condition of the geomorphology of the river. So all the data is collected because we want to make sure the river is in a natural of its flow and the river process has not been disturbed by the other activities. Okay, for example, like the channelization, deforestation, and so on. Okay, so the criteria of the river that has been selected is based on the REFCON method, where there are about five criteria which have to identify through the study area. Okay, first is what is it any dam or any river construction of dam further upstream of the river that has been selected. So it will, of course, will change the geomorphology of the river at the downstream. Okay, second, the criteria is is it any activities at the surrounding catchment area, so that will affect also on the floodplain area, will affect also the geomorphology of the river. So that's why all the river has been selected at the mountainous area, because we want to maintain what is the good quality of the river, especially based on the based on the morphology.
Okay, thank you very much. Very nice explanation. And thank you very much for the interesting study. So we need to move on to the next presenter. So let me see who is the next presenter. Yes, we have the next presenter, Datu Feroz Hanif Muhammad Ahmed. And he will be presenting on eco-composite porous concrete drainage system and alternative mitigation for urban flood management. So the presenter is not here with us, but we will be just playing the recording. Those participants who are interested to ask any question, you may drop your question and your email address in the discussion forum, and we will get the response from the presenter and send to you. Okay, so thank you very much. So please proceed for the video recording of the next presenter, Datu Feroz.
Assalamualaikum and hi to all participants. I'm Nur Yasmin Farham binti Harum from University Technology Mara, Shah Alam, Selangor. On behalf of my team, consists of Dr. Feroz Hanif Ahmad, Dr. Hidayat, and also Dr. Abdul Rahman Muhammad Sam from University Technology Malaysia, Johor, Malaysia. I would like to present entitled Eco-Composite Porous Concrete Drainage System and Alternative Mitigation for Urban Flood Management. So, basically, this study has been conducted due to some issues related to flash flood, specifically in Shah Alam, Selangor, due to improper drainage system, such as due to clogging and also sedimentation. So this kind of technology, which is eco-composite using RHA or RHA, will be used as the porous media and effective microorganism (EM) in these concrete drainage systems. So what is effective microorganisms technology? It is basically EM was founded in the early 1980s by Dr. Turo Higa, which is a horticultural professor from Japan. EM basically naturally available, not genetically modified, and environmentally friendly. Okay, EM also contains mainly three types of, which is bacteria, which is lactic acid bacteria, photosynthetic bacteria, and also yeast. And then this slide shows the existing conditions before the eco-composite drainage system are implemented in Shah Alam, Selangor, which is the study area of this topic. And also from this slide also shows the implementation of eco-composite porous concrete drainage covers in Shah Alam, Selangor. And then this slide shows the preparation of porous concrete for drainage cover. And this is what we call the structure and the cross section of the EM composite scupper drain, or we call it as EM-CSD, consists of, as you can see from this slide, EM-CSD with glaze and also the filter of this structure. And then the implementation of EM-CSD in Shah Alam, Selangor, as you can see, before the installation of EM-CSD and after the installation of EM-CSD in Selangor. and this is what we call the EMCSD installation in Shah Alam, Selangor. And then about the composite porous concrete slab design selection evaluation based on what we call 4 evaluation criteria, consists of design, cost, creativity, and also capability. From these criteria, all these criteria, we identify that design 4 is the best option based on all these criteria. Okay, right. So next is in terms of the cost comparison between the existing drainage system and also the EMCSD. So in terms of cost of labor and also cost of machinery between the existing drainage system and EMCSD, it shows from this slide that the high of cost saving when using EMCSD compared to the existing drainage system. And then in terms of concrete design, where the quantity of EM was 10% by replacing the amount of total water content, and also concrete mix for control concrete mix which is without EM, and EM concrete mix with addition of EM was the same. And also several laboratory testing have been conducted in order to define in terms of the strength and also the workability of the mixture. So from the laboratory testing, we find out that in terms of the workability, where workability of EM concrete improve compared to control concrete without EM. And also in terms of compressive strength, also EM concrete is higher compared to control concrete sample. And the last one in terms of temperature increase test, where the temperature of the EMC sample is lower and cold compared to control concrete sample. So as the conclusions from this slide, the new revolution using EMCSD system to replace the conventional drainage design system will definitely give benefit to public in reducing flash flood and maximize water filtration, and also the specialty of EMCSD, including the cost saving and the high strength on the design mixture with lower temperature as compared to the existing drainage system, have been approved by this preliminary study. And also implementation of EMCSD in drainage system able to reduce urban flash flooding as well as protection of groundwater and surface waters, and to reduce the stagnant water in the drain which cause mosquito habitat, and also to reduce the vandalism of the cover slab. So that's all from me. Thank you.
Okay, so thank you very much. We are done with all the presentations today. So let me just conclude. Let me first remind you that if there is any question related to this last presentation, you may drop the question with your email address in the discussion forum, and we will get the answer from the presenter and sent to you through email. So thank you very much for your kind participation in this session today. So we had a very interesting studies on the overall the cost system analysis, the wastewater treatment system, the overall the urban storm management systems, flash flood systems, different the biocomposite materials which are helping to avoid the flash flooding. So several interesting studies which supporting the green environment and smart water resources management system we have in fact had in this session. So I would like to thank all the presenters for all the outstanding presentations, and I would like to thank for all the participants for their active participation, particularly raising the very interesting questions in the session. So thank you very much. So see you in another session later on. Okay, thank you. Okay, salam alaikum and very good evening in Malaysia. Bye bye.